Okay, so we're going to start talking about rational numbers. Our learning target today is going to be classifying a number as rational or irrational based on its decimal equivalent. So first we have to talk about what is a rational number. Okay, a rational number is going to be any number that you can write as a fraction. So that's going to mean, for example, whole numbers, fractions, obviously, and then terminating or repeating decimals. So when I talk about terminating or repeating decimals, a terminating decimal is going to be a decimal like 2500, 0.25. It's a decimal that stops. It may stop at the tenths, it may stop at the hundredths, it may stop at the thousandths, but it stops. A repeating decimal would be a number that goes on and on forever, and it has a pattern that repeats. So it may be a 3 that repeats. And remember, we use bar notation for a repeating decimal. We'll talk about that in a little bit. If it is a number that goes on and on and on in no repeating fashion, and it never stops, that's what we call an irrational number. Very few numbers are irrational of what we're going to be talking about. So when I say we're adding and subtracting rational numbers, that's going to be any number that can be written as a fraction, positive or negative. Okay, it could be a fraction we're adding, it could be a decimal we're adding. So an irrational number is a decimal or a number that goes on forever with no repeating pattern. These are things like pi. Pi is an irrational number. 3.14159, blah, 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 blah. Goes on and on and on. It never stops. It never repeats. Okay? Pi will be considered an irrational number. That's probably the one you're most familiar with. So when we come down here and I look at A, B, C, and D, classify each as a rational or irrational. It's kind of like pick the one that's not like the other. What would A be, rational or irrational? What do you think? Rational? And you can just put an R if you want to. How about 19? It's rational. It's a whole number. How about C? Now this has a pattern, but is it the same pattern that's being repeated over and over? Is it the same number that's being repeated? No. Okay. It's a pattern, but it's not to be a repeating decimal. It has to be the exact same thing repeated over and over and over. This is 28, 228, 2228. Okay. We don't know what it's going to keep doing. Okay. So what would this one be considered? Irrational. See this little dot, dot, dot? That means it keeps going. So this is going to be irrational. And then -8 would be rational. Okay, so go ahead, come down here, do the exercises. You can just use an R for rational and IRR for irrational. Determine which ones are rational, which ones are irrational. Okay, so what would number 1 be? Rational. It's a whole number. Number 2 is also rational. Has a terminating decimal. It stops. So I can make that a fraction. 582, it's a whole number. That's rational. 0, rational. 1/5, it's already a fraction. And what's the definition of rational number? It can be written as a fraction. Right? Number 6, irrational. It goes on and on forever, has these dots, and there is no repeating pattern. So it is irrational. Number 7. Oh, I lied. There was only one irrational. I tricked you. Because the 0,9 is repeating. Yes. See how 0,9, 0,9, 0,9? That one was my fault. I messed you guys up. That one's rational. See, even I make mistakes. See what happens when I don't look at it close enough and I'm on very little. Okay, number 8. 4.34 repeating. So the 3 4s repeating over and over and over, which means it would be rational. Number 9 is already in fraction form, so we know that is rational. And number 10 is a terminating decimal, so that means it's going to be rational. So there was one irrational number. All right, let's flip to the back side. So how do we convert a rational number to a decimal? In other words, what is another word I can use for rational number? Fraction. Fraction, another word. Just a fancy, rational number is a fancy word for fraction. So how can I convert a fraction to a decimal? What does a fraction bar mean? What operation is a fraction bar?
Divide the top number by the bottom.
Yep. We're going to take the numerator divided by the denominator. A fraction bar just means division. So if you're not good with your terminology, or if you've got those summer cobwebs going on, that's top divided by bottom. So our learning target that the state of Missouri says is that you need to be able to change a fraction to a decimal by using long division. Okay. So if I want to change 9/10 to a fraction, how am I going to do that? What would I do? Divide. 9 divided by 10. So my numerator goes on the inside, my denominator is on the outside. But how many times will 10 go into 9? 0. So what do I need to do? We need to add a decimal and a 0 and bring your decimal up. Okay? Summer cobwebs. We'll get them out. So we have a 0 there. So how many times will 10 go into 90? 9 times. So 9/10 is, guess what? 0.9. How do we say that decimal? 9/10. So our fraction sounds exactly like our decimal. Okay? They're not all like that, but some of them. All right, let's do 1/8. 1/8. So we're going to take 1 divided by 8. We're going to add a decimal point and a 0. So how many times will 8 go into 10? 1 time. Then we do 1 times 8 is 8. 2 remaining. Well, I have 2 remaining. Can I put 0.1 remainder 2? No. Keep bringing down zeros. So we're going to bring down another 0. How many times will 8 go into 20? 2 times. So that's 16. And we have a 4 remaining. Let's try one more 0 and see what happens. How many times will 8 go into 40? 5 times. So you're done. 8 times 5 is 40. So we have no remaining number left. So 1/8 is 0.125. Okay, let's look at 2/9. So we're going to do 2 divided by 9. I'm going to add my decimal point and 0 because I know I'm going to have to. 9 won't go into 2. 9 goes into 20 how many times? 2 times. So that's 18. I have 2 remaining. I'm going to add a 0 and bring it down. 9 will go into 20. 2 times. What's going to happen each of these times? What's it repeating? 2, right? It's repeating this 2. So 2/9 is 0.2 repeating. Remember that bar means it's repeating. That's bar notation. Okay. So wouldn't it be nice for a bunch of these to not have to do the long division? You just know what they are. You don't want to have to do long division on all of these. So these are what we call your need to knows. These are your ones that you're memorizing over the weekend. Okay. So we're going to go through. I'm not going to make you do long division on all of these. Okay. We're going to go through these and we're going to figure out what they are. I'm going to help you along the way. Okay. So 1/2. 0.5. Think money. What's half of a dollar? It's 50 cents. Okay. Thirds. Close. What do you think? Repeating. Thirds is a repeating. Okay, because I can't equally break 1 up into 3 equal parts. It is a 0.3 repeating. So 0.3 repeating. Yes. Okay. So then 2/3. Does anybody know what that is? 0.6 repeating. With the bar over it. You have to have the bar over it because the bar is the difference between 3/10 and 0.3 repeating. Big difference. Okay. 1/4. 0.25. 25 cents. It's like a quarter. 1/4 of a dollar. 1/4. So why don't I have 2/4 on there? Yeah, 2/4 is the same thing as a half. So I don't need 2/4. Because if you reduce it, it's 1/2. Okay. 3/4. 0.75. 75 cents. Okay. All right, now we get into our fifths. What is 100 divided by 5? 20, right? So if I have one of those fifths, it's like, think about pennies. If I were to split $1 up between 5 people, how much would everybody get? 20 cents. So 1/5 is 0.2. It's 20 cents. How about 2/5? 0.4. It just goes up in increments of 20 cents. So 3/5, 0.6, and 4/5, 0.8. Okay. 6 are a little bit harder. 6 are just one that you have to memorize. Okay. 1/6 is 0.16 with the 6 repeating. Only the 6 repeating. I don't really have a good way to tell you otherwise. You can remember as 1/6 and it's 1 and 6. So come up with a way that you're going to remember that. All right, 5/6. Why did I not put 2/6 on there? It reduces down to 1/3, right? 3/6 is 1/2. 4/6, 2/3. Okay. So 5/6 is 0.83 with the 3 repeating. Yes. I did 5 divided by 6, but I'm just telling you what it is. There's no, that's just one you have to memorize. That's a hard one that you just have to memorize. Okay. 1/8. We did it up here. Remember? Look up here. We did the long division, didn't we? And so what was the decimal equivalent when we divided 1 divided by 8? 0.125. Again, these are just the long division ones. They're just ones you have to memorize. I don't have a fancy way for you to remember it like these over here. Okay? This middle row are really the ones you need to work on, big time, because they're just memorizing. The other ones I have patterns for you on all of them. Okay? 3/8. If I do the long division, 3 divided by 8, it's going to be 0.375. If I do 5 divided by 8 and do that long division, 0.625. And then 7/8 is 0.875. So when I do that long division, that's what it would be. I could make you do the long division on all of that, but that'd be a lot of work. All right, 9ths. When we did our long division up here on 2/9, what did we find out is repeating? The 2. Well, 2/9, so 0.2.